Okay, copy and complete the table. So the first thing we will do is we will look at the set notation. But in order for us to look at the set notation, we need to look at the third box that's over here. So let's look at the -1 that's included. We look at the 3 that isn't included. So when we're writing our set notation, we need to write in that form there. So we use curly brackets for set notation. So it's open brackets, it's curly brackets, x such that is a 2 dots, right? And then we start off with the -1 is less than and equal to, that's why we have the dark dot there, right? X and is less than 3, because the 3 is not included as indicated in the number line. Now we continue. We need to say x is an element of what? Now the continuous line that we see here, right, that continuous line is known as real numbers. That means all the numbers included. Therefore x is an element of real numbers. The interval notation, remember the interval notation uses square brackets and round brackets. Square bracket is when it's included. So in this case here the -1 is included. So we say square bracket -1. And we get the 3 that's not included, so we say 3 with the round bracket. Remember round brackets when the number is not included. Okay, for the last box here, we need to draw the number line. Now we look at the information in the first box here, right? So we have x is an element of natural numbers. So natural numbers are numbers that start from 1 and 2, 3, 4, 5 onwards. So we will start with those numbers, right? So they are giving us the number 3, which is not included, and they are giving the number 8, which is not included because there is no equals to there. It's just less than. So we draw a number line, right? We have our 2 arrows on either end, and then we put the number 3, 4, 5, 6, 7, and it tells us to stop at 8. Now when we're drawing our number line, remember the 3 is not included, but x is an element of natural numbers, so therefore we want the number 4, the number 5, the number 6, and the number 7, but 8 is not included, so that's our answer. So 1.4.1, we're given a fraction. There is a square root on the top, and there's a numerator and denominator. So we need to take this into consideration when answering these questions. So 1.4.1 states, for which values of x is m undefined? So if you were to look at the numerator and the denominator, this is m is equal to, right, the square root of 2x plus 2 divided by 2x plus 4. Now we know that in order for something to be undefined, it must be like 5 over 0, 2 over 0. So therefore the denominator must be 0. So all we need to do is take the denominator, and which is 2x plus 4, and we equate it to 0, because that part must be 0 in order for us to get an undefined answer. So 2x plus 4 is equal to 0. So we solve for x. So we have 2x is equal to -4, and we divide both sides by 2, and x is equal to -2. And if we substitute this -2 into the 2x plus 4, which is our denominator, we will arrive at an answer 0. So therefore these are the values of x for m, this entire question, to be undefined. 1.4.2, for which value of x is m equal to 0? So let's write the question down. So we got m is equal to square root of 2x plus 2 divided by 2x plus 4. Now in order for me to arrive at m equal to 0, therefore the numerator must be 0. So it would be 0 divided by 2, or 0 divided by 4, 0 divided by 1, 5. Anything that 0 is divided by will always be 0. So therefore I need to take the top part and equate it to 0. So I can take the entire top part. It's fine. I can say square root of 2x plus 2 is equal to 0, or I can take just the inside part of the square root, but it's fine. I can, just to show you that the numerator is equated to 0. So when I want to get rid of the square root, I square both sides, so I'm left with 2x plus 2 is equal to 0. So all I've done is I've squared both sides, so the square root disappears. So it means the same thing if I took the inside part of the square root. So continuing, I got 2x is equal to minus 2. Divide by 2, divide by 2, and then I've got x is equal to minus 1. Substituting this into the equation or the numerator, you got 2 times minus 1 is minus 2. Minus 2 plus 2 is 0. So square root of 0 is 0, and 0 divided by the denominator will give me an answer of 0. 1.4.3, for which values of x is m non-real? So writing the question down. Okay, remember, non-real numbers are numbers that, for instance, an example of it would be a square root of a negative number. These numbers don't exist. For instance, you have a square root of 25, minus 25. There is no answer for that. If you punch that in the calculator, you won't get an answer. Square root of minus 10, you won't get an answer. Right? So basically the idea here is to make the 2x plus 2 that's inside the square root a negative number. So all I need to do is I need to say 2x plus 2. Now in order for me to make it a negative number, that means it must be less than 0. Any number below 0. Right? So below 0. So less than 0. Right? So all I have to do is treat it like a normal equation. So I say 2x is less than minus 2. Divide by 2 on both sides, and x is less than minus 1. So if we punch in any number less than minus 1, so for instance, if I punch in minus 2, I'll have 2 times minus 2 is minus 4. Minus 4 plus 2 will give me minus 2, and the square root of minus 2, we can't find the answer for that. So therefore it is non-real.